Okay, we're going to go over some of the main things from skill 6 and 7. We're going to look at the Desmos warm-up that you guys did and how to walk through the steps for completing the square for a couple of those problems that you guys struggled with. And then we're also going to look at simplifying the quadratic formula. So I'm going to look at this first problem. It's from slide 3. And the directions were to solve by completing the square. So I just want to remind you guys that completing the square is just a process of making a square so that we can use square roots to solve. So if you guys remember in the last lesson, we were finding x-intercepts maybe of an equation that looked like this. We were able to do that by square rooting once we got this perfect square alone. So kind of our goal in completing the square is to take an equation that doesn't look like this to make it look like this so we can use that same method of square rooting. So the first thing we're going to notice is that 4 is a perfect square, but with a lead coefficient of 3 here and a middle term of 2, this is not going to work as factoring as a perfect square right away. So that constant is the thing that we want to replace. We're not putting new variables into the problem. We want to put new constants into the problem, how we're allowed, adding to both sides, in order to make something that could be a perfect square. Now in the notes, we saw the patterns and we developed kind of a little mini formula that helped us find out the number that would complete the square, and that was using this b over 2 squared. But that pattern only worked when the lead coefficient was not equal to 3. So the 3 here is an issue, and the way we're going to deal with that in this situation is we are simply going to divide by 3. As that's okay as long as we do it to both sides of the equation. So we would be left with x squared minus 2/3 x equals 4/3. We now have something where we are looking to figure out the constant to add on to this equation in order to make this factor as something that is a perfect square. Okay, so that constant now can follow the pattern that we saw in our notes of this b over 2 squared. In order to do that, I would take the b value of negative 2/3. I want to divide it by 2 and square it. So that looks a little bit frightening, but remember to just write it out in a way that's more understandable for us. We have negative 2/3 being divided by 2. That is negative 2/3 times 1/2. The 2's will cancel out, and that would leave us with negative 1/3. And then don't forget, we still need to square that, which would give us 1/9. So apparently 1/9 is the value that will make this quadratic factor as a perfect square. We are welcome to add in whatever we want to the left side of the equation as long as we also add it to the right. We're now going to go through and make common denominators on the right side so that we can add these together. So I'm going to think about this as 12 over 9, giving me a total of 13 over 9. And on the left side, the whole purpose of writing a perfect square or completing the square was to factor it as something squared and be able to use square roots. So remember that if you're looking for two of the same factors, I'm going to write this off to the side because some people were struggling with this earlier. When you go to factor this and you know it's supposed to be a perfect square, you know that you need the first terms and the next terms to be the same. These should be the same factors. The only way you can use two of the exact same thing to get x is if they are both x, then they'll multiply to be that x squared. Two of the exact same things to get 1/9 would be 1/3. And so you can see that if we multiplied the first together, we get the x squared. If we multiply the last terms together, we get the 1/9. It's these middle terms that are supposed to make that negative 2/3. And you can see they would make a 1/3 and another 1/3, and those would combine together to be 2/3. If you want them to specifically make negative 2/3, then both of these 1/3 would need to be negative. And that's how we would factor this. So a little bit shorter process, if you understand it well, is I know the beginnings have to be x due to that. 1/3 would be the number squared to make 1/9. And since I'm making negative terms in the middle, I would use a minus sign here. So I'm going to square root both sides. I get x minus 1/3. Don't forget to include the plus or minus in this situation. And as I square root this fraction, the numerator is not something that simplifies well, but the denominator, square root of 9, would just be 3. And I'm going to add 1/3 to both sides And so I will have this result. Another way of writing this result, you could write them all over that single common denominator. So you have these solutions. You could separate them also into the two solutions that they are, one that's adding the square root of 13 and one that's subtracting. Okay. Now we're going to look at the problem that was on slide 5 about rewriting in vertex form. So we were given this equation, and our goal is going to be really similar. This is our vertex form. We're building again that perfect square portion. So we're looking to build that perfect square portion. And where do we put the stuff that doesn't fit into the perfect square? We can have this coefficient multiplying it here and this constant being added off at the end. So that's kind of the structure that we're looking for. So right away, 3 is not going to be something that helps factor as a perfect square because 3 is not a perfect square. So right away, I kind of want to, in my mindset, split these pieces up that with these x's, I'm going to work on completing the square, but the 3 isn't going to be part of that. It's going to be something that belongs in the k value. Now I want to make our perfect square here, but just like above, right now I can't use the pattern that I found because I have a coefficient of -2 in front of the x squared. So I'm going to actually factor that -2 out. It's going to kind of act like my a value. So I'm going to factor out a -2. I'm getting these values by taking the terms that were previously there and dividing them by -2. I'm not factoring -2 out of the -3 because it wasn't part of the group. It was outside of that group. I now have like an a value of -2, and part of my k value is going to be this -3. And I now have something set up in the parentheses that I can use that little formula to complete the square. So remember, this was how the pattern that we saw, that we take the b value, divide it by 2, and square it. So I'm going to take -1/2, divide by 2, and square it. -1/2 divided by 2 is like -1/2 times 1/2, which gives us -1/4. And then I'm going to square that. So that's going to give me 1/16. So I know the value inside this polynomial that I'd like to add is 1/16. And I want to add an equivalent amount to the other side. You can't just make changes to the equation. You can only do this because of the addition property of equality, where we can add whatever we want on one side because we're balancing it out by adding it on the other side. Now, a small warning about this 1/16. Our eyes see 1/16, but we have to be aware of what we've really done here. So side note, if I write this and I decide to add 1 here, I've written the number 1, but what is it actually worth? It's actually worth 1 being multiplied by 3, which is 3. So just because we write down a number, it doesn't mean we've really added that much to the equation. We wrote down the number 1/16, but that 1/16 is in a quantity that's being multiplied by -2. So really, by writing the 1/16 in a quantity that's getting multiplied by -2, I have actually added a quantity of -1/8 onto my equation. It doesn't look like -1/8. It's written in a different way. It's written as 1/16 times -2, but it is worth 1/8. So to add something to the other side that is equal, what I need to be adding to the other side is -1/8. Okay? So I now have -1/8 plus y equals -2. This should now become a perfect square. And then I have my -3. We've looked at the factoring of this. Our hints here, if that's an x squared, we're getting an x. If this is a 1/16, we're getting 1/4. And if we want to make negative terms in the middle, then those 1/4 times x's should be negative. This almost looks exactly like vertex form. The only thing that's not okay is the position of that 1/8. So I'm going to go ahead and add 1/8 to both sides to get y completely alone. And I will have y equals -2. X minus 1/4 squared. And to combine these together, I'm going to think of 3 as 24/8 to have that common denominator. And so this is going to give me 23/8. And this is going to give me my equation in vertex form. Okay. All right, the last thing I want to talk about is simplifying quadratic formula. So I actually want to talk more about once you've set up the quadratic formula, not making certain errors in simplifying. So here are 3 different possibilities that you might get once you get something that's written as in that quadratic formula, and we just want to make sure you're going to simplify it correctly. So the first thing we want to talk about are the radicals. You really need to simplify that radical. In this first one, we have square root of 24. I'm going to try and think of 2 things that multiply together to make 24. If I can find a perfect square, I'm going to do that. You have other ways to simplify radicals. If you break down into the prime factors, that's totally fine as well. Square root of 4 is the same as 2, so I have 2 rad 6. So this problem is going to come 2 plus or minus. The square root of 24 is now 2 rad 6 over 6. Now some things to be aware of. The 6 cannot simplify with the other 6 because this 6 in the numerator is not really a 6. It is the square root of 6. That's a different number value. This other 6 is not included in a radical, so that's not something that can simplify. Now 6 does divide into 2, but what you need to remember is that 6 is a denominator for both of these terms. You don't have to write it like this every time, but your brain really needs to understand that this is what it's representing, so that you can't just cancel out the 6 and the 2 and not have that first term anymore. So really, if this is what it's representing, that first fraction would reduce to 1/3. So would the second fraction. Be really careful. This 3 cannot divide anything about this 6 because it's not part of a square root. And so I have 1 plus or minus rad 6 over 3. So how could I see that before? I can see that these all have a common factor of 2, and I can divide out a 2. You need to make sure you're doing it for both terms in the numerator and the term in the denominator. You don't have to write it separately. I'm just trying to make sure that you understand where that's coming from. In the second problem, the radical we're looking to simplify is the square root of 18. So when I think about 18, 9 comes to mind as a perfect square, and 2. So this will be 3 rad 2. So this would be 4 plus or minus 3 rad 2 over 2. Now be careful, like we said before, this 2 can't actually simplify with the 2 inside the radical. It can simplify with the 4, but again, mindset, even if you don't write it like this, do you understand that this is what it's representing? These don't simplify. These can. So you have a couple of options here. If you want to keep it as one fraction, what you see there is the most simplified version of the fraction. If you want to simplify the 2 and the 4, you can, and you can call that 2, but then you have one quantity that's fraction now and one that's not. Okay, those are worth the same amount. And then lastly, I'm going to look at this last example. First thing I'm going to do is break down square root of 72. 9 and 8. 9 is a 3. Oh, but then 8 is square root of 4 and square root of 2, and 4 is a 2. So 3 times 2 is 6. Rad 2, if you saw that faster than me, good job. And then, so I'm going to have 8 plus or minus 6 rad 2 over 36. And again here, you don't have to write it like this, but you need to understand. There are factors that 8, 6, and 36 all have in common. 6 is really tempting to divide straight into 36 and write as 6. You can do that, but not if you're also considering the 8. So again, you really need to understand when you're simplifying that that 36 is a denominator for both of them. You can simplify them separately. 4 goes into 8 and into 36. 6 goes into itself and 36. So one way to write this would be like this. That's the most simplified version of each of the fractions. If I want to keep them as one fraction like is written here, I would want to think of a factor of 36 that divides 8 and also divides 6. So like for example, all of those are divisible by 2. I could factor a 2 out of the numerator and denominator and cancel it out. And in that case, I would get 4 plus or minus 3 rad 2 all over 18. And then I'd have to decide if I could simplify further. 18 and 3 have common factors. 18 and 4 have common factors, but 18 and 3 and 4, 3 and 4 specifically, don't have any common factors. So if you want to leave it as this one fraction, that's as simple as we can get that.